Hello students. So in the previous video, we discussed about the properties of ROC, and we took some examples on Z transforms and locating ROC poles and zeros. So in this video, we'll take some more examples, different kind of them, and we'll see how to locate the ROC poles and zeros in these cases. Okay. So the first one is find the Z transform of x of n is equal to 1 by 3 to the power of n sine pi by 4n into u of n. Sketch the ROC and pole 0 location. So we have to find the Z transform of the signal, and also we have to locate ROC and pole 0 location. So this is the problem. Now going to the solution, so let's start with the definition. Summation n varying from minus infinity to plus infinity x of n z to the power of minus n, and given x of n as 1 by 3 to the power of n sine pi by 4 n into u of n z to the power of minus n. So this one, okay. Now u of n is present for n greater than or equal to 0, and it is 0 for n less than 0. So our limit will be from n is equal to 0 to infinity 1 by 3 to the power of n sine pi by 4 n into u of n. And I think I forgot z to the power of minus n here. Yes. Now this term, let's convert this into exponential. So that gives n is equal to 0 to infinity 1 by 3 to the power of n. So inside this, e power j pi by 4 n minus e power minus j pi by 4 n divided by 2j z to the power of minus n. I will take this 1 by 2j outside, and if I split this, summation n is equal to 0 to infinity 1 by 3 to the power of n e to the power of j pi by 4 n z to the power of minus n minus n is equal to 0 to infinity 1 by 3 to the power of n e power minus j pi by 4 n z to the power of minus n. Okay. And the next step, if we combine all the terms which are present, which are having n common here, so 1 by 2j summation n is equal to 0 to infinity, we have 1 by 3 e to the power of j pi by 4, I think I'll take this n here outside, pi by 4 z inverse to the power of n minus summation n is equal to 0 to infinity 1 by 3 e to the power of minus j pi by 4 z inverse to the power of n. Okay, and I think z inverse is not here, into z inverse whole to the power of n. Now this one is in the form of like some geometric series. N is equal to 0 to infinity a to the power of n is 1 divided by 1 minus a, where a is less than 1. So that means this term and this term, both of them should converge for ROC. So when the ROC x of z will converge if these two are less than 1. So that is the meaning. So we'll apply this. So what we get, 1 by 2j into 1 divided by 1 minus 1 by 3 e power j pi by 4 z inverse. So this is the first one, and minus 1 divided by 1 minus 1 by 3 e power j pi by 4 z inverse, and here it is minus j, not plus j. Okay, so this is the simplified version. Now if you go further, I think if we take the LCM, we get z minus 1 by 3 e to the power of j pi by 4 divided by z here, and in the numerator we get 1 divided by, and minus 1 divided by 1 minus 1 by 3, sorry, z minus 1 by 3 e power minus j pi by 4. Now if z goes to numerator, if you take this LCM, z minus 1 by 3 e to the power of j pi by 4, z minus 1 by 3 e to the power of minus j pi by 4. I'm going to simplify this directly. Z minus 1 by 3 e to the power of minus j pi by 4. Okay, minus z plus 1 by 3 e to the power of j pi by 4 here. So might be wondering what happened to this z here. I think now if you convert this uh, e power j pi by 4 as cos pi by 4 plus j sin pi by 4, I think this z and z will get cancelled, and you will remain with you can take this 1 by 2j into 3 common, so we will remain with minus 1 by root 2 plus j 1 by root 2 plus 1 by root 2 plus j 1 by root 2. These two will get cancelled here, and plus jj, and we'll get 2j 1 by root 2 divided by z minus 1 by 3 e to the power of j pi by 4, and z minus 1 by 3 e to the power of minus j pi by 4. So we'll end up with 1 by 2j into 3, and here you will get 2j 1 by root 2, 2j will get cancelled. Yes. I think I will keep this here itself. One, okay, let it be. You can take this at outside here and keep it here. So this is the solution as 1 divided by 3 into root 2 z divided by z minus 1 by 3 e power j pi by 4. So this is the reason I don't usually go for full solving. It will take some time. Okay. Anyhow, this is the end answer you are supposed to get for this one. Now if you observe these two terms here, so this term and this term, this should converge to get the ROC. ROC both sum should converge. We have two sums there, so both of them should converge when 1 by 3 e power j pi by 4 z inverse is less than 1 and 1 by 3 e power minus j pi by 4 z inverse is less than 1. So that gives us now we have this mod term here, this mod term. Inside this we have e power plus j pi by 4 and e power minus j pi by 4. So you will see that the angle, if you look at this, anyhow, if you look at this, this e power j pi by 4, this can be expressed as cos pi by 4 plus j sin pi by 4. Since it is mod, if you take the magnitude of that, that will be square root of cos square pi by 4 plus j, no, I think j term won't be there, plus sin square pi by 4. So you will get 1 by root 2 square plus 1 by root 2 square. That means you will get 1 by 2 plus 1 by 2, it is square root of 1, which is nothing but 1 itself. So this value here will be equal to 1. So it will remain with 1 by 3 z inverse less than 1, and if you take this one, you will get the minus sign, but if either it is plus or minus, so you can apply this a square plus b square only. So that means again you will get for e power minus j pi by 4 1 only. So 1 by 3 z inverse less than 1. So therefore 1 by 3 less than z and 1 by 3 less than z, or you can simply write z greater than 1 by 3. The meaning of this, we have a circle of radius 1 by 3 and the ROC is outside this circle. So this is the ROC. Now coming to this poles. So if you observe this, poles and zeros, poles and zeros. So first I will take zeros. 1 by 3 root 2 into z is equal to 0. So that gives, if equate to 0, then we will get z is equal to 0 itself. So we have a 0 at z is equal to 0. Now coming to poles, we have z minus 1 by 3 e to the power of j pi by 4 and z minus 1 by 3 e to the power of minus j pi by 4. And if you look at this, these two terms, if you take the values will be 1, but the angle we have plus pi by 4 and minus pi by 4. That means at, if you equate to 0, z is equal to 1 by 3 e to the power of j pi by 4, z is equal to 1 by 3 e to the power of minus j pi by 4. If you compare this is the z term, it is r e power j omega. If you compare this, z is equal to r into e power j omega. So this gives the radius value and this term is omega. So here omega is equal to minus pi by 4 and here omega is equal to plus pi by 4. Okay, that means at z is equal to and r is equal to 1 by 3 in both the case. So that we have a circle of radius 1 by 3 and the poles are located at two different angles. One is at omega is equal to pi by 4 and another one is at omega is equal to minus pi by 4. So that is the meaning of this. So in the previous case we didn't have any poles at particular angle. So here we have the location of poles which is present in a particular angle that we have to mention there. So this is about poles and zeros. We have one zero located at z is equal to 0, that is origin, and we have poles, two poles. One is, both are located at z is equal to 1 by 3. One is at the angle plus pi by 4, another one is located at an angle minus pi by 4. So these two we have to locate this. So taking all this data, if you go for plotting this, so we have a circle. First thing is we have a circle of radius 1 by 3. One by 3. Now ROC will be outside the circle because z is greater than 1 by 3. That is the reason. Here. So this is ROC. Now coming to poles and zeros. First thing is we have a 0 located here, and second thing, pi by 4, 45 degree. I'll mark somewhere here, plus pi by 4. Another one is minus pi by 4. I'll mark here. Now you can join them or you can show them with a dotted line. This is minus pi by 4 and this one is plus pi by 4. Okay, and these are located at r is equal z is 1 by 3. One is at an angle plus pi by 4, another one is at an angle minus pi by 4. Poles, and this one is 0. 0 at z is equal to origin, and these two are No need to write this, just for your information I am writing this. No need to show that. Poles at z is equal to 1 by 3 and omega is equal to plus pi by 4 and omega is equal to minus pi by 4. So this is just for your clarification. I am writing this poles and 0. This uh, this much is sufficient, and this is the region of convergence. This is how if angle is there, we have to locate poles and zeros with a particular angle. Moving on to the next one. Here we have a signal x of n is equal to alpha to the power of mod n, where alpha is less than 1. So we have to find z transform, and the answer is, and the question is, what is its ROC? So that is the question here. What is its ROC? So observe the signal alpha to the power of mod n is there. So that means alpha, this n can take positive value and negative value as well. But whatever alpha is going to take, the mod alpha, that value will be less than 1 itself. Okay. So if it is taking negative value, then it will be less than -1. If it is taking positive value, then it will be less than +1. That is the meaning of it. So we have to consider both the condition here. Given x of n is equal to alpha to the power of n. Now, if n takes positive value, then it will be x of n is equal to alpha n into u of n. That is the positive time sequence. If n takes negative value, then it will be alpha to the power of minus n, and negative values varies from u of minus n minus 1. So this is only for minus infinity to minus 1, and this is from 0 to infinity. So combining these two, we have our x of n. So this is for if n takes positive value, and this one if n takes negative value. Mod n is there, so we have to combine both of them. I'm not going to plot that signal here because we don't know what is alpha. Now coming to the solution for this, x of z is equal to summation n varying from minus infinity to plus infinity x of n z to the power of minus n. So let's substitute this value alpha n u of n plus alpha to the power of minus n u of minus n minus 1 z to the power of minus n. Now this we have u of n and u of minus n minus 1. I will take the limit directly here. So u of n is present from 0 to infinity. So therefore for n is equal to 0 to infinity, alpha n z to the power of minus n plus summation n is equal to minus infinity to minus 1 alpha to the power of minus n z to the power of minus n. Now we can combine this. N is equal to 0 to infinity alpha z inverse to the power of n. Now I will be interchanging the limit from n is equal to 1 to infinity. So that means these two becomes positive. Alpha n z to the power of n. Now let's combine the common powers here. N is 0 to infinity alpha z inverse to the power of n plus n is equal to 1 to infinity alpha z to the power of n. Now in the ROC, these two terms should converge. So we are going to apply the geometric series here. So based on that, I can write x of z is equal to 1 divided by 1 minus alpha z inverse plus 1 divided by 1 minus alpha z. But here we have the limit 1 to infinity. Therefore, this will be alpha z. So summation n is equal to 1 to infinity is a to the power of n is a divided by 1 minus a, where a is less than 1. So this is what we have applied. Next, if you simplify this, so you will get 1 minus alpha z if you take LCM, and plus 1 minus alpha z inverse into alpha z divided by 1 minus alpha z, 1 minus alpha z inverse. If you simplify this, 1 minus alpha z plus alpha z minus, here alpha into alpha is alpha square z and z inverse. So these two become 1, these two get cancelled, 1 minus alpha z, 1 minus alpha z inverse. So finally we'll end up with this term 1 minus alpha square divided by 1 minus alpha z inverse so this is x of z. Now coming to this ROC, x of z will converge if 1 minus alpha z is less than 1 and 1 minus alpha z inverse is less than 1. Okay. Now if you simplify this, you will get, if you take z, let me see here. So alpha z inverse and alpha z. So I made a mistake here slightly. Alpha z should be less than 1 and alpha z inverse should be less than 1. If you simplify this, so z goes to this one and z less than 1 by alpha, and here alpha is there, z goes to this one. So first, so here z, here z is greater than alpha. So based on this, we can write z is greater than alpha but less than 1 by alpha. Okay. So here they are just asked to what is its ROC. So this is what the ROC is. Z lies between alpha and 1 by alpha. Now if they ask you to plot this ROC, I'm just showing you the ROC here. Z is less than alpha but less than 1 by alpha but greater than alpha. Now alpha value will be less than 1. Suppose if I take alpha is equal to 1 by 2, so then it will look like 1 by 2 less than z less than 1 divided by 1 by 2. So that means z will be between the two circles, greater z will be between this 1 by 2 and 2 circle. So this just for an example I'm showing you. Okay, like this you can plot the ROC by taking the value for alpha. So moving on to the next problem. So given x of n is equal to 1 by 2 to the power of n, u of n minus u of n minus 10 So find Z transform and plot ROC, look at poles and zeros. So this is the question. Now if you look at this, you have u of n minus u of n minus 10, and the limit will be, you will be having a signal from 0 to 9. So this is what you're going to get, u of n minus u of n minus 10. If you plot this graphically, so 1 2 3 4 5 6 7 8 9. So this is the signal. You'll get a limit from 0 to 9. And based on this is important because we have to take the limit for the signal. So that's why x of z is equal to, from the definition, x of n z to the power of minus n. So n is equal to minus infinity to plus infinity. X of n is 1 by 2 to the power of n. U of n minus u of n minus u of n minus 10 z to the power of minus 1. Now this signal is existing only from 0 to 9. So therefore from 0 to 9 its value is 1. So our limit will be from n is equal to 0 to 9, 1 by 2 to the power of n z to the power of minus n. And let's combine this. N is equal to 0 to 9, 1 by 2 z inverse to the power of n. Now from geometric series we have, if n is equal to 0 to n, a to the power of n. Okay. So we have one minus a to the power of n plus 1 divided by 1 minus a if a is not equal to 1. Okay. Or this will be equal to n plus 1 if a equal to 1. So this is from geometric series we have. So based on that, let's apply this one. X of z is equal to 1 minus, in place of a we have 1 by 2 z inverse, and in place of n we have 9 plus 1 divided by 1 minus 1 by 2 z inverse. So that allows us to 1 divided by 1 by 2 z inverse to the power of 10 divided by 1 minus 1 by 2 z inverse. Now if you simplify this, so you will get 1 minus 1 by 2 to the power of 10 z to the power of minus 10 is divided by, here if you take this, z minus 1 by 2 divided by z. Okay, so this can be written as 1 divided by But if you take this outside, we'll get z to the power of 10 minus 1 by 2 to the power of 10 divided by z minus 1 by 2. If we take this as LCM, okay, I'll explain this step. Z to the power of 10, 1 minus 1 by 2 power of 10 . I'll take the LCM here, that gives z to the power of 10 minus 1 by 2 to the power of 10 divided by z to the power of 10, and here z minus 1 by 2 divided by z, and this z cancel, here it becomes 9. So if I take this outside, 1 by z to the power of 9 into z to the power of 10 by 1 by 2 to the power of 10 divided by z minus 1 by 2. Okay, yes, or you can write it like this: 1 by z to the power of 9 into z minus 1 by 2. In the numerator, I can just have z minus 1 by 2 to the power of 10. Can take this one out. Yes. So that's the final answer. Now coming to the ROC. ROC x of z. So if you look at this, we have a term here, one by 2 z inverse, and ROC, if you observe this, ROC will be entire z plane except at z is equal to 0, because we have a finite sequence here. Y means, now look at the signal, it is varying from 0 to 9, that is, it's a finite value. Okay, so that means since x of n is finite, the ROC is entire z plane except at z is equal to 0. So this is from the property of ROC. You have to remember, if we have a finite sequence, then the ROC will be entire z plane except at z is equal to 0. So this is what we are going to get as the ROC, entire z plane. Now coming to poles and zeros. Poles and zeros. So numerator says z to the power of 10 minus 1 by 2 to the power of 10. Now z to the power of 10 minus 1 by 2 to the power of 10 is equal to 0. So the meaning is z to the power of 10 is equal to 1 by 2 to the power of 10. At location, this means at location at z is equal to 1 by 2, we have 10 poles, sorry, 10 zeros. And this 1 by 2, it will be in circular nature. Why means it will be throughout the axis. Now coming to the denominator, z to the power of 9 is there, that is the poles. Here the first one is zeros. So coming to the poles, z to the power of 9 is equal to 0, z minus 1 by 2 is equal to 0. So z is equal to 1 by 2. So remember, this case and this case is different. That means if z to the power of 10 is equal to 1 by 2 only, that means at 1 by 2 we have 10 number of zeros. But here both the power z to the power of 10 is equal to 1 by 2 to the power of 10 means at 10 different places exactly at a distance of 1 by 2 from the origin we have 10 different zeros presented. This one is z to the power of 9 is equal to 0 means we have 9 poles at origin, that is at z is equal to 0, and we have one pole at z is equal to 1 by 2. So this is the meaning here. Now this one is slightly different. It means at z is equal to 1 by 2 we have 10 zeros. So these zeros should cover the entire 10 different places at 1 by 2 radius from the origin. Now how to plot this? So first thing is the ROC is entire set plane because x of n is finite. Now coming to poles and zeros, so this is the origin. Now coming to poles and zeros, so first I will locate zeros here. Now here somewhere we have at this distance from 0 to this is the point 1 by 2. Now starting from this we have to, from this we don't have any circle, but at a distance 1 by 2 from origin we have 10 poles. So 1, so 10 zeros, 1 here, 1 here, 1 more here. Okay, so this 1 2 3 4 5 6 7 8 9 10. So all these zeros are located from at a distance 1 by 2 from the origin. So combining this we have 10 zeros. Okay, so this is how we have to locate. So 10 zeros are located. Now coming to poles. So coming to poles, we have 9 number of poles located at the origin and 1 pole here. So 1 pole here and 9 poles here. 9 poles, 1 pole at z is equal to 1 by 2. 9 poles at z is equal to 0. And these are 10 zeros at z is equal to 1 by 2 from origin. So this is how we locate poles and zeros for this. Okay, so I hope you have understood this method of locating ROC, poles and zeros. In the next video we'll take the properties of Z transform and we take some examples on those properties. Okay, so if you have any doubts or any queries, please do reply to the video or comment in this video. Thank you for your time.